So here's just a little walkthrough of the drinking water treatment process. I've got a number of different demonstrations lined up for you today. First things first, we're going to have to create some dirty water that's going to be pulled from a conventional source, such as a dirty river, something like that. For that, I've got this little cup of dirt right here. We're going to pour that just in all this clean water over here that was probably treated pretty recently. Want to get a good mix on it, so I brought in this nifty little blender. Get it blended nicely for you. I'm just going to add some coarser debris to demonstrate the filtration. Or the intake screens rather, sorry. So here I've got two different cups set up because I want to show one as a control and then one treated. So as you can see, it's pretty important to have those screens on the intake to capture some of the coarser debris that would otherwise make it into the treatment facility and have to be dealt with there. This next one even shows the further importance of that process. Alright, so now we've got two samples. Both of them are pretty murky looking, right? Well, now comes the magic of coagulation and flocculation. So we've got some stuff here. It's called alum. Alum is aluminum sulfate, and it helps particles suspended in water stick together, which increases their mass and allows them to settle a little bit faster. So for this demonstration, I'm going to just pour a little bit of alum in this one here on the right. I'm going to go ahead and give that a good stir. The amount of alum that is added is a little bit more strategic than what I just demonstrated. They've got their ratios a little bit more dialed. And when it's first added, it's mixed pretty rapidly during the coagulation process to get it to distribute throughout the sample. And then it moves into the flocculation, I have a hard time saying that word, area. And that's where the mixing is a little bit more controlled. And that encourages the particles to hit each other, but not so fast that they're going to end up bouncing off of each other and not sticking. So we want them to hit, and then we want them to settle out in that basin. And so I think I've probably mixed it enough. We'll give it a little bit more. I should have mentioned that before this coagulation and flocculation process, there's some other tactics that are employed. Aeration to oxidize iron 2 and magnesium 4, I guess. And helps with the removal of hydrogen sulfide. Also, chlorine can be added to this process to help with disinfection throughout the procedure, but that can lead to some byproducts such as THMs that are not exactly desirable. So I'm not going to add any chlorine at this process. Alright, I think I've mixed it sufficiently. Now you're going to be able to watch this settle, and I'm going to speed up the time at which this video is playing back. So what you just watched was the sedimentation process. In a drinking water treatment facility, this will oftentimes be in a number of basins that the water slowly flows from one to the next to give time for the particles to really settle out. The settling velocity is what's important here. It needs to be happen faster than the water makes its way from the inlet of the settling basins to the outlet of the settling basins. And after the sedimentation settling process comes the filtration process. And in a lot of drinking water treatment facilities, they rely on sand. Sand acts as a pretty dang good filter for the stuff that we're trying to filter out, which is largely just whatever is left hanging around in the water. As you can see at the end of that process, here was the stuff with alum added, and here was the sample without alum added. So it's pretty impressive how well that alum works. And for the next demonstration, not exactly sure how well this is going to work, as it's kind of my guinea pig test, but I've got some sand on top of some gravel, and we're going to pour the sample water that had alum added to it through this filter in hopes that we get at least a little bit of improvement here. So let's see what happens. And usually in a drinking water treatment facility, the sand layer will be much thicker than what I'm working with here. I believe the gravel layer will probably be thicker as well, and it may be layered, with thicker gravel on the bottom, a little bit finer, all the way up to pretty fine sand. So hopefully we can see an improvement here. Water definitely seems to be taking its time moving through, which is a good sign. And then finally, the last step of the drinking water treatment process is disinfection. And there's a couple different prominent ways of going about disinfection. One is adding chlorine, and chlorine has a benefit of killing bacteria, virus, and protozoan cysts right there. And then it has a residual that lasts through the distribution facility, so through the pipes there's still some chlorine in there, and it may be able to kill those pathogens that are lingering around or introduced later on. Another up and coming treatment mechanism is UV light, which also kills those. UV light doesn't have the benefit of hanging around in the water to kill anything that's introduced later on, so oftentimes some chlorine will be added, but I'm just going to simulate some UV light here with this bright flashlight that I have for cycling. And I'll go ahead and pour the last little bit of the water through our filtration process. And then so once it's disinfected and that's all gone down, it'll oftentimes be collected into a basin at the end in order for it to be stored before it's pumped to the consumer, so pumped to your and my faucets for us to drink. And actually, it looks like that sand here, I gotta turn off my UV disinfection over here. But as you can probably tell from there, it looks like our sand filter worked pretty good. That's just an old peanut butter cartridge that I drilled some small holes on the bottom of and collected some gravel and sand from Moonstone Beach. So I'm gonna go ahead and abort that mission so I could show you. It doesn't look too bad. I don't know if it's quite ready for me to drink, but that's a good conceptual demonstration of the process that occurs on a much larger scale with much larger basins and much more refined, dialed in procedures. But as you can tell, a few simple household items, you can go from this to this with relatively little effort. I hope that was somewhat informative for you, and thanks for watching.